Have you seen the problem though?
Nah, not yet. Cause you emailed me. Hold on. Yeah. What's up?
I was just saying one of my friends had it easier because one ball hits another ball that's at rest and then it goes off kind of like in a V shape.
Okay.
And then, but they're at different angles.
Which problem is this?
This was the Billards ball in unit 12.
Filler balls or?
It's the last one in the homework that's due today.
Okay. Well, did you figure it out, or did you like?
No, someone else kind of wrote out the steps, but then I was just like, sure.
Oh, so did it all? Okay.
Yeah,
You're still confused as to how it's supposed to be done.
exactly.
What's
the lines this time?
Oh, you did?
No.
Alright, yeah, is that usually? Oh my god, I'm so scared. I'm so confused. Where's this one at? No, it's not it.
You were in class one day.
Yeah, I wasn't there. Yeah, I was not there. I was back in Naperville, and I think Gladowski also went to Naperville.
That day?
No.
Or the weekend?
No, he used to live in Naperville.
Oh.
I emailed him saying like, hey, I'm trying to be there. And then he goes like, oh, okay. And I told him like, yeah, I'm gonna be I was like, I'm gonna be there. I'm gonna be there for like decent. I'm gonna be there for all day in Naperville. And he was like, oh, you live in Naperville as well? And I was just like, is he saying as well as in like he also does, or?
Because he said stuff about him taking the train here, right? I was talking about CTA.
Oh, that could be him. Okay. All right. So what is it? So the buildings. It was elastic collision, I'm assuming, right?
Yeah.
Stop.
As long as your thing has different angle numbers, it's not 45 and 45.
I don't think I've had like the exact answer, but I'm sure.
No, yeah, that's fine.
Two balls hit a wall, exposure, more than two, bumper cars,
After that.
bumper cars two, bumper cars two.
Wait, which unit are you
What's
Yeah. Billard balls? No.
the heck? Lots of collision.
Yeah.
Why do I have?
Yeah, lots of collisions. Yeah.
What?
It's,
Oh.
that's weird.
Yeah, only have explosion, and then I have bumper cars, unless bumper cars would be kind of so, is this still momentum, right? Yeah.
I think momentum seems like it's
So which one? Which problem 1, 2, 3, 4 resolve?
Oh, you found it? No problem.
I think.
With the final speed of both the cars.
Yeah, I don't have that question. What? Wait, what's the question asking? What is the total? Which one? Or which problem?
Well, I wasn't able to get these two. 'Cause you get these two the same way. So basically, if you solve one, you get the other. And then, um, and then the other question, like this one was fine, because that was, I believe, yeah, the total momentum. So that was
That's
fine.
right, that's fine.
And then, the joules, I'm pretty sure you got from this.
Okay, so the other two, are your values the same as me? I don't think so. No. No, your values are the same. That's what your answers are. Okay, so white billiard ball with a mass of that is moving directly right with the speed of that.
Yeah.
Springs velocity and collides elastically with a black billiard ball with the same mass of that. That's initially at rest. The two collide elastically and the white ball ends up moving at an angle at horizontal swing angle, and the black ball ends up moving at an angle below with that swing angle.
But they're not the same angle, right? You don't have the
No,
same
yeah, they're not the same angle. Also, your friend had the same angle?
Yeah.
Wow, lucky duck. That is so lucky. Just notice that. Okay. So basically I'm assuming, did you get them right?
Well, yeah, but like,
Oh,
I didn't know how I got it, or I don't know.
Wait, how did you get it?
Because someone else helped me, and they couldn't really explain it. And
Explain it. Okay. 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 So, so they're asking what's the final speed of the white ball? See, I found some that have to deal with um, this is probably good. Okay. This is final speed of the white ball. An object with a total mass of that, so you had an explosion. So you had an explosion, right?
an explosion.
Did you have what is wrong with this?
I don't remember reading.
So you guys only had bumper cars and billiards.
Yeah.
This is strange.
I had collision with friction, and then spring-loaded collision, and then bumper cars 2, and then billiard cars.
Yeah. Well, you got the final total momentum correct, right?
Yeah.
Okay.
So I'm not like worried about
Okay.
it being due. It's just I didn't know how it
So you don't. Yeah. So you don't know what the speeds are. Okay. So you use momentum basically to figure out the speeds, obviously.
Yeah, so how I started off, I did the weight times the initial velocity, and then that got the momentum, and then I was gonna use that to solve for the speed in the x direction, but like, or I thought that was momentum in the x direction, and then I had to figure out the y with the angle, and then do Pythagorean theorem. But I don't think that worked out.
Okay, so what you can do, when you solve for one of them, you can solve for the other one. Basically, you solve for a relationship between the two velocities in certain directions. So remember last time, like during class, we had to do momentum x and momentum in the y direction?
Yeah, we were given that.
Right. So if you do momentum in the x direction, here, let me see if I can try to find that. So, find the problem.
Okay, oh, you found it.
Yeah. I just want to see if like they were similar to the other problems. Completely wrong. That's okay. Okay. So here we'll use your values. So what were the values? So we'll use that one. It's a black ball.
Yeah. So the masses are 1.61 kg.
Which we'll say this is 1 and this is 2. What was 1?
The masses are 1.61 kg.
1.61 kg.
And then initial velocity is 3.01 meters for the one ball. 3.01
meters per second?
Yeah. And then the angle of the white ball is 51 degrees. So angle above.
Oh, this one.
Yeah, it's 51. And then below is 39.
So this one's 51 degrees, and this one
39.
Is 39?
Yeah, 39.
So you said that was 39 degrees. So this is, okay, so this is, so that's initial. So the number 2, you got, what's the mass of this number 2?
The mass is the same.
Oh, okay. But you know that V2 is going to be 0 because it's at us. Okay. Cool. So, okay. This is fun. So it's basically the same idea when you used, you know how I told you before that the initial is equal to the final, right? Because momentum is conserved.
Yeah.
So we know that, I'm going to say initial and final, we had that, so basically initially, if you have mass of 1, velocity of 1 plus mass of 2, velocity 2, is initially is going to equal to the same idea, right? Plus mass of 2 v2. The only difference in this case is that the elastic collision is more towards at an angle rather than just head straight on. So therefore, this one over here, this one you're going to have to deal with, wow. This one you're going to have to deal with trig. So, okay, so basically what you're going to have to do is a system of equations in order to solve for using the x and the y components.
I thought there would be a different way. That's how my friend solved it.
Oh, your friend solved it a different way?
No, that's how my friend solved it, and I was confused.
Oh, okay.
I was hoping there was a different way.
Nah, it's not good. I mean, there probably is, but there is some type of trig involved because they are going off at angles and trigs.
Well, yeah, the trig part is fine. It's just the system of equations.
Oh, some of the equations what gets it?
I guess. This was just a bunch of stuff.
Yeah. All right, that's okay. We'll try it. So basically, this is like your general form. General. But now we're gonna want to solve for it in the x direction, and then the y direction. So basically, just walk me through it. So, initially, what you got?
The momentum equal to.
So 1.61, right?
Yeah, 1.61 times 3.01 equal to the mass, or 1.61, and then Vx, which would be cosine of the angle.
In the x direction?
Yeah.
Yeah, so what was that, 51? Oh my gosh.
And second mass.
which is the same thing, yeah.
But its velocity is 0. The initial velocity is 0.
The initial velocity is 0. Yes, this is correct. But now because you don't know what the final velocity is, what are you gonna do?
Just put V.
Yeah, just put down v2. Okay. So this v2 is gonna denote this guy right here. This is gonna be v2, and then this is gonna be v1.
Is it still going to be cosine?
Yes. Well, in this case, I mean, I think so, yeah.
Cosine of
Oh, so this one, yes. This part where you're gonna have to be really careful, because it is the opposite side. They give you the absolute value of it. So yeah, so basically you solve all of this, so come up with the general equation. What's the type of numbers, basically? Do you want me to like go through it just so you can solve it? Yeah.
And then I just get V squared from, or not V squared, V2 from just doing that.
Essentially, yeah. Well, in this case, you're gonna get, this one you're gonna solve for the final V2. Yes. And then you need to also solve for, oh, wait a minute. No. I forgot. You need to be careful as to what is initial and what is final.
Oh, yeah.
Yeah.
So that's another V.
Yes, so
Okay.
we have to make sure we know that there's this one and there's also this one. These are our two unknowns that we just don't know. So yes, make sure you always write that down because that was the initial. We cannot assume that the initial is the final, even though given to us that the initial velocity is that. So typing this stuff in, what do you get for the left-hand side?
So we get 4.846 or 4.85.
All right, cool, 4.85, and then do this times that. What do you get?
Wait, what times what?
1.16 times cosine of 51 degrees.
Oh. 1.013.
1.013, and there's going to be V1, and then do 1.16 times cosine negative 39 degrees.
Oh, okay. You said it weird.
Oh.
And there, 1.25.
And V2. All right, so this is going to be equation 1. All right, so now you're going to solve for it in the y direction.
So it's, then I just put them on top of each other and just solve for, or just do substitution, I guess.
Yeah, you could either do substitution, you could use system of equations, but in this case, because you're only dealing with two variables and you realize that initially all in the y direction, exactly. So you're just gonna have 0 is equal to, and that's gonna be 1.61 mass V1. Yeah, exactly. 51 degrees plus 1.61 V2. Yeah. I write too fast for the board. So yeah, so then from that, you're basically going to find what you can do in this sense. You can either, option 1 is either to find V1 is equal to a blank of V2, or obviously in return you can do V2 is a blank of V1.
Yeah.
Right? And then you basically take those values, place it into here, and then you can solve for V1 or V2, and then you already have the relationship between V1 and V2 and solve for that one. Yeah.
All right.
Does that make sense?
Yeah.
Okay.
So I guess it was a lot easier to see now.
Okay.
Maybe I just had to do it the second time.
Just want to make sure. Yeah. Because when in doubt, when dealing with these types of problems, is always of P initial is equal to P final. Or yeah. Just thinking of momentum initial is always conserved, right? And then if you're dealing with angles, you're gonna have to deal with some type of x and y component. And then if you have two variables, most likely use system of equations. But yeah. But the only difference is know that if you do have something, because you just got lucky, you got really lucky that this is equal to 0, so you can automatically
Oh, if it
find.
was coming in at an angle.
Exactly. Say if it was like this, say if like the ball was coming in this direction to hit a ball that's here that made it split like that and that, but this is actually your X and Y axes.
See, how would you solve that? You would have to split up that one into its X and Y's, and then that one's X and Y's and its other X and
Yeah.
Y.
That's what it gets annoying. But
Is that later this year, or is that physics 2?
I mean, honestly, that you can honestly still do that with this one. It's just a little bit more work. I mean, what you could do is if you really could do this or have a really good visual in mind, you could rotate the axes. Rotate the axes so that this becomes the X direction, and then this becomes the Y. Does that make sense?
Yes.
You could do that, but the issue is you just have to be careful about this data and like changing this data to technically that data, and I don't know. There's a lot of different changes of angles that's going to happen, but if you have something like that, you're definitely going to end up with like a number v1 plus some number v2. This equation is going to be the same idea: some number v1, some number v2, blah blah. And then you could.
6 of those.
What's up?
Except like 6 of those.
Yeah. I mean, you could. Yeah. And you could probably use. Have you used matrices before?
Yeah.
Yeah. You could use some matrices, and honestly, just plug that into calculator and solve it real quick. But gotta be careful. Yeah. So yeah. Do you have any other questions?
No, that was it.
That was
That was really just it.
Sweet. All right. Did you want to maybe take a look at like future homework, or are you like done?
Physics wise, I think I'm done. I'm gonna do some kind of math. Probably both tonight.
Okay.
No offense to you.
Let's check. I have a lot of other ones. That's not. I have no idea. I have fluids and what's it called? Fluids and mass heat transfer. It's a CHE course. Yeah.
Is that an elective for it?
It's a prereq for a lot of higher, like 400 level CHE classes.
Oh, so
Is
I'm
that
guessing
in-
you're gonna do Cotone. Well, it's smart one to do, for sure.
What's up?
So it's a smart one to do, for sure.
Yeah, some people are actually like kind of the opposite about it. Some people are like, I don't want to do this because they're shortening my graduate program, and therefore there's some students that are like, they believe that they want to learn more and take a longer time to digest everything, so they have a concrete basis. I mean,
Why is it rushed when it's like in 5 years?
I mean, it's not necessarily rushed, but I mean, yeah, you are compacting basically 2 years of coursework into one.
Yeah.
If you think about it, but some people like find undergrad a little bit easier, like getting your bachelor's is easier, so they can squeeze in those master classes just to make it slightly difficult for them. So then they can like still. I don't know. It's just the benefits right now outweigh the digestion of material. At least for me, at least. But so for other students, it's like, no, like I need to like learn everything. So, yeah. All right. Okay. Well, if that's the case, then
Really just took up 25 minutes of your time for that.
that's fine. That's fine. That's what I'm here for.